So today we're going to be solving systems of inequalities by graphing. And so if you notice, I've got three solutions up here. Okay, and I actually graphed these on GeoGebra. And so we might bring the netbooks in and use GeoGebra as well. But if you notice, you're going to do a lot of shading today. And so these first two lines, one is dotted, one is solid. And notice how the shading is. So where do you think the solution would be here? If I was to specify a region and say I've got region 1, 2, 3, 4, where would you say the solution would be? 1, good, because it's where it's shaded both. Okay. Now what about here? I've got 3 regions. Where would you say the solution is?
2, 3, 2. None of them.
None of them. And why is it none? Because there's no intersection. Okay, there's nothing that's shaded both. Okay, so here I've got 3 regions. Where do you say the solution is there? 2, because 2 is shaded both ways. 2 is shaded both by the blue and the pink. Okay, and so that's what we're going to be looking. We're going to be looking for where's the intersection point. So with lines, the intersection was an actual point. With inequalities, the intersection is a whole region, a whole area. So let's go ahead and look at an example. So I went ahead and passed out to you basically the same graphs we're going to be doing in class, and so that way you should have something in your notes. And so this first one says y is less than or equal to 6. So what you're going to do is imagine the inequality isn't there, and you're going to draw a line for y equals 6. What type of line is y equals? Y equals is what? Straight line. It's actually what type of line though? Do we remember? Solid. It'll be a solid because it's equal to what else? Horizontal. Good. So I'm going to go up here to 6. 1, 2, 3, 4, 5, 6. And I'm going to draw a line at y equals 6. And so remember, y is horizontal. What is vertical? X. So you're just going to, and so if you want to go ahead and use one of the colored pencils, the thing I suggest is that you use a light colored pencil first. So don't pick black or blue. You're probably going to want to pick something in the orange category. A light green, a light blue. And then now I've got to figure out which direction do I shade. And so if you notice, that's a less than sign, so it says y is less than 6. So are values below the line less than, or are values above the line less than? Below. So all you're going to do is lightly shade. So go ahead and grab your colored pencil and lightly shade below the line. Now I kind of have a hard time with that here. I mean, I'll try and, but it's kind of hard because I can't lightly shade. Okay, but go ahead and lightly shade below the line. So when everybody's got that done, we'll go ahead and be ready to move on to the second line. Now I don't know if you guys were young enough, but one of the ad campaigns for Ziploc baggies was the yellow and blue makes green seal. And so what they did with one side is they made one side yellow and they made one side blue, and so then when you put it together it made green. So they always said you knew it was sealed if it was green, and that was a big thing. And so here, that's kind of neat. If you did something like that, your area where you would shade it would be colored that way as well. I know it's corny, but that's okay. I have to get you guys going somehow. So let's look at the next line. It says y is greater than -3 plus x. Now as it is, this doesn't look quite like something that we've seen before, but this does. What form is that in? Y equals mx plus b. So very first thing, what is the y-intercept here?
-3.
The y-intercept is -3. So what you're going to do is go to -3, and you're going to put a dot. So go ahead and put a dot at -3. So if you want to pick another color, that's fine. Put a dot at -3. What's the slope going to be here, folks? 1. So that means I'm going to go up 1 over 1. Up 1 over 1. Now real quick, before some of you start connecting the dots, what type of line am I going to use here? I'm going to use a dotted or a dashed line because there is no equal to symbol right here. Okay, so since there is not an equal to symbol, oops, having trouble with the pen, there we go. Since there's not an equal to symbol right there, I am going to use a dashed line.
So if it's equal, wait, I thought the one on the top wasn't, I thought that was just greater than.
Nope, it's greater than or equal to.
So
Oops.
then that makes it.
Evidently my line didn't work. Let's try again. Let's try and get that. Well, we'll try and get it over here, and then we'll try and get that done. So go ahead and draw your dashed line in. Okay, let's see if it works now. Not getting that to go in, so I'm just going to have to draw it in manually. Okay, so I should get something that looks like that. So now I need to find out which side of the line do I shade. Do I shade the top left side or do I shade the bottom right side? So a good rule of thumb is to pick a point.
0, 0.
0, 0, good point. So let's plug in 0, 0. So if I plug in 0, 0 and up here, okay, so actually I'm going to plug it in over here. 0 is greater than negative 3 plus 0 because we need to plug it in on the inequality side. So is 0 bigger than, what do I get on the right side? Negative 3. So is 0 greater than negative 3?
Yes.
Yeah, so I'm going to shade top left or bottom right? Which one?
Top left.
Top left, good. I'm going to shade the side width.
Do we shade the whole thing?
Yep. And so now,
Like even that white one?
yep, you're going to shade everything to the top left of the blue line. Now what's going to end up happening is you're going to see when you draw that in that you have a region that is shaded 2 colors.
You do. You do.
Okay? That region that is shaded 2 colors is your solution. Now, what some of my kids in the past have done is they have really darkened that region up. So instead of just kind of leaving it shade, they've darkened it so that I know that that is where their solution is. If you want to use a third color that's a darker third color and kind of outline that region, that's a thought too. But this is what I'm going to be looking for.
So it would be like the
Yes.
this thing.
So here's your solution. Your solution is going to be right here, and this is going to be a dashed line, so make sure that's not solid. And then what it's going to do is it's going to go up here, and here's going to be your boundary. Your boundary is going to be this y equals 6 line right here. Okay, and so your solution is everywhere in the middle. So it's going to kind of look like a triangle that keeps on going forever and ever.
Oh.
This is
And that's not
Thank you.
Alrighty, if you're done, I want you to go ahead and move on to number 2, and I want you to find the slope and the y-intercept of the first equation. Next time.
Oh, you did that.
Yep. So let's go ahead and find the slope and the y-intercept of the first one. So I want you to go ahead and try and graph that line.
rock.
What's the slope? Negative 3. What's the y-intercept? 4. Good. Okay, as you're graphing, when you get done, I want you to go ahead and look at the board and see if yours, in fact, is going to look like the one that we have on the board.
Yeah. Well, now that you've shown me.
This is just.
Oh, dang it, you don't do the line. Do you do the line on 4, straight line? For the lines?
What do you mean, the straight line?
Like what we did on the last
No,
problem?
because the last problem only has one number.
Ah,
Cross that out.
Okay, so when you get done,
are we doing the
you
same
can
color?
check out and see if you have, in fact, the line that I have up here on the board. And from the looks of things, it looks like you guys are all on the right track. So now we need to figure out, what side of the line do you shade? So let's pick a point. What point do you want to pick? 0, 0. So let's plug in 0, 0. So as I plug in 0, 0, I'm going to plug 0 in and 0 in right there. So I end up getting 0, is less than what number?
4.
4. Is that true? So I'm going to shade on the left side of that graph.
What is not equal to?
But it doesn't have to, because if you remember, it says less than or equal to. And it won't be equal to. The only time it will be equal to is if it is on the line itself. So when you get that done, you can go ahead and start working on the second line, finding the slope and finding the y-intercept. Now on the second one, you've got to do a little manipulation to the equation, okay? Because if you look, notice that's not in slope-intercept form. So the easy way to do that, I'm just going to add 2x to both sides. So I end up getting y is greater than 2x minus 1. Your slope is 2. What's your y-intercept?
-1.
-1. Nice job. So, you can see that those two actually intersect at a point.
They do.
They do.
And it's a dotted line.
And what type of line are you? Yep, and it's a dotted line. Good job. See if I can get the dashed line to work this time.
Yeah, I haven't worked on
I'm not very good at drawing straight dotted lines.
Oops, I drew it the wrong color, but we'll change that.
Yeah.
Okay, so now you got to pick a point. So if we pick the point 0, 0, it is in fact on one side of the line. So if I plug in 0 here for x and y, do you get a true statement, yes or no?
Yeah.
Is 0 greater than -1? Yep, so I'm going to shade what side, the left or the right?
Left.
Left. So here you go. And so now you should see that your area that's shaded isn't necessarily a triangle. Okay? Because it's kind of a sideways V to the left. So it's sideways V to the left, so we're dealing with this right here that's dashed. And then this side right here that's solid. And then everything else to the left of that.
So that's the answer. Is the
So your
sideways.
answer is everything that's shaded here in gray. What that means is that every point that is in this shaded area will fit both of those inequalities. So here, it's not just one answer like you got before. It's an infinite number of solutions.
Cool.
Still looks ugly. Mixing colors is not more.
All right, let's go ahead and look at the next one. Now I have to figure out my slope and my y-intercept. So what do you need to do on the third one first? Divide by 4. So if you divide by 4, you should get y to be greater than or equal to -3/4 x plus 1.
1.
So what's your y-intercept?
1.
1. Slope is
3/4.
-3/4. So you're going to go down 3 over 4. Down 3 over 4. What type of line? Solid. So when you go ahead and get that line drawn in, I want you to pick a point on one side of the line or the other and find out what side do you shade.
Right.
So what side do you shade?
Right.
The top right. Good job. Because you end up getting a false statement when you plug 0, 0 in. When you plug 0, 0 in, you end up getting 0 is bigger than 1, and that's not the case. Alrighty, Alrighty, so my last one is in standard form, so let's remember our little trick to find the standard form slope. Slope is, in this case, negative, and remember, here's my A, B, C. So my slope is negative, what over what? 3 over 4, good. What is my y-intercept going to be? My y-intercept will be negative 8 over 4, which, as you've already said, is negative 2. Good job. So here's negative 2, and then I've got a slope of negative 3/4, so down 3 over 4. What type of line? What type of line is it going to be? Dashed. Yep, dotted. We'll see. There. Now I need to figure out what side. Now don't automatically assume that this is going to be like the very first one we looked at on the first page. So I'm going to pick a value. I'm going to plug in 0, 0. So if I plug in 0, 0, I end up getting 0 is what?
0 is less than.
Lyra is less than negative 8, and so is that true?
No.
No, so which way are you going to shade? On the bottom. And so is there a solution on this one?
No.
No, so this is actually a no solution, and as you said, yes, they are inconsistent, so very good. Now I think that's good enough. I don't think we're going to look at that last one because you guys picked up that stuff pretty quick. That last one is a vertical line, and then it's going to be a line on the diagonal. Okay, so you've got a few problems for tomorrow, or for Monday. It's a few problems, and here you go. 5 problems for me is all you have, and we've already done 3. Okay, 7, 8, 10, 12, and 14. 7, 8, 10, 12, and 14.